Standard temperature, and to some degree this is arbitrary, we will consider to be 0 degrees Celsius or 273 Kelvin. Notice there's no degree here when we talk about Kelvin. We just say Kelvin. Standard pressure is considered to be 1 atmosphere, or in other units, 101.3 kilopascals, or the pressure of the atmosphere at sea level, which is probably where most people live. So it kind of makes sense. Water freezing and where most people live. At STP, 1 mole of gas will occupy 22.4 liters. This is a number you're going to get very familiar with, and it's designated as V sub little m. For the time being, we'll treat all gases as if they are at STP. The volume occupied by 1 mole of gas is called the molar volume, and it has the symbol V little m. And at STP, that volume is 22.4 liters. And now let's relate it to Avogadro's number. 1 mole of gas is equal to 6.02 times 10 to the 23rd particles of the gas, and that's 22.4 liters. This statement does not depend on the type of gas. It is true for all gases. This seems counterintuitive that even at STP, all gases occupy 22.4 liters, because some gases they have a greater molecular mass than others. But in a gas, the molecules are so far apart that they take up almost no space. The volume of a gas is mostly empty space. There's nothing there. You could consider it a vacuum, frankly, between the gaseous molecules. And that is regardless of the type of gas. So when it comes to volume at STP, all gases are created equal. So 1 mole of helium gas occupies 22.4 liters at STP, and 1 mole of HCl gas occupies 22.4 liters at STP. At STP, 1 mole, or 6.02 times 10 to the 23rd representative particles, okay, that's Avogadro's number again, of any gas occupies a volume of 22.4 liters. That is called the molar volume of a gas. We have a little equation here where N is the number of moles of the gas, V is the volume of your sample of your gas, and Vm is 22.4 liters at standard temperature and pressure. An inflated airbag requires 60 liters of nitrogen gas at STP in order to protect the occupant of the vehicle. How many moles of nitrogen gas would need to be created in 40 milliseconds to inflate the airbag? Well, we just had the equation where the number of moles, N, is equal to your sample volume divided by the molar volume. So it turns out you don't need this at all. That's just thrown in there for educational purposes, but not needed for the problem. So the volume is 60 liters. Vm is 22.4 liters. You can see how liters cancels out, and you do the division, and you get 2.7 moles. So let's check it with the answer here. 2.7 moles.